All right, we're looking for a Pythagorean triple such that a, b, and c add up to 1,000. A, b, and c are going to be positive integers that form the sides of a right triangle, with c being the hypotenuse, and you can see a couple of examples in front of you. Right now, I want you to take a pause and actually try this yourself. Just click on the link in the description, and there's a little app there that you can try to find Pythagorean triples, and specifically the one that we're looking for. All right, let's see what we can do. We have 2 equations and 3 unknowns, so we're going to need some help here. And today the help's going to come from Euclid, who has a way that we can approach this left-hand equation. And we're actually going to build a circle out of a squared plus b squared equals c squared with that substitution in the box. Now, when we build our circle, keep in mind that a, b, and c are going to be positive. And so x equals a over c and y equals b over c are both positive. So I only care about this top right, or this first quadrant of the circle. And this is a 2D curve that we're seeing here, but we're trying to reduce the amount of unknowns, and in this case, reduce the dimension. And so we're going to represent this curve by just this yellow flat line here. And how we're going to do that is by drawing a line from 0, -1 up to the curve. And for every point on the red curve, we can just talk about k, which is the positive x value, where the blue line intersects the positive x-axis here. First, we'll build the equation of this line, just using y equals mx plus b, and that is going to be our equation of the line. And what are we going to do with this? Well, when y equals 0, x equals k. It's the distance down the positive x-axis. So we can actually solve for k and get this formula for k. And what we notice here is that if we flip k upside down, that's actually the slope of the line. And so we can replace the slope with 1 over k. I want to know, when does this line intersect this circle? Now I have 2 equations and 2 unknowns. Here I'm treating k as a constant, and so we can actually solve this by substitution. In the first equation, which is the equation of the line, we can solve for x squared, and then replace that or substitute that on the right-hand side and try and solve this equation here. Underlined, this is really a squared minus b squared being factored into a minus b, a plus b. And then we get this equation here, which is what we're going to want. We'll save in the top left the equation of the line, because we'll need that later. And now let's draw our attention to this main equation here. We have something times something else equals 0. So that means either the first thing or the second thing has to be 0. If it's the first thing, well then y equals -1, and this is actually going to give us the point 0, -1, which is the intersection of the line and the circle. It's just not the intersection we're looking for. Solving for the other y value, that gives us the y value of that white dot in the top right, and we can substitute that value of y, or that formula for y, over onto the first equation and get the x. Here we've converted our 1 to this fraction of something over itself, which is just 1, in order to simplify this, and we get the x value for the white point and the y value. So notice how we've gotten x and y both in terms of k, which seems to be rather helpful here. Everything's in terms of one variable. And what I would like to do is just say, okay, if x equals that and x equals a over c, can I just say that 2k equals a and 1 minus k squared equals b and just be done with it? And not quite. Just because a ratio equals a ratio doesn't mean the numerator equals the numerator, okay? Or the denominator equals the denominator. What we need to do is actually ensure that there's no common factors, that is a reduced fraction. And how we're going to do that is by representing k as a reduced fraction, so as n over m. So the greatest common denominator of n and m is 1, and that's what's going to do the trick for us. Here we can note also that n has to be less than m, and that's because we're in the unit circle. This is the distance down the positive x, and if k was bigger than 1, we would have left the circle. So replacing k with n over m, we can then do our algebra here and see what our formula for x and y are going to be. I'm going to multiply both by 1, and here I'm writing 1 as m squared over m squared, and I'm going to get an expression for x in terms of n and m, and an expression of y in terms of m and n. And now I can actually say the numerator equals the numerator, I won't show this, but this has to do with the GCD of n and m being 1, and that extends further to these ratios that we have here. And now we have a formula of 3 variables in terms of 2, a, b, and c, in terms of just m and n, and this is going to prove handy for us. I do want to note, now that we have these formulas, we actually don't need n and m to be relatively prime to each other. You can plug these formulas for a, b, and c back into the left-hand equation, and it will always work, and you won't have to resort to the GCD being 1. So we can drop that condition now. Now we can turn our attention to the second equation, and we'll notice that even after we apply our formulas, well, now we have one equation with 2 unknowns, but that's a little simpler than 3 equations, or 2 equations with 3 unknowns. We get a cancellation here, and we see after factoring that m, which is the larger of the 2, has to be a divisor of 500. And I would say it can't be that big either, looking at that second to last line. 25 squared is already bigger than 500, so anything 25 or above can be eliminated. And if we're trying to get mn plus m squared to be 500, 20 is probably a good guess, and here it turns out to work. If we plug m equals 20 in, we get that n equals 5. Notice how m is bigger than n, like we wanted, and notice how they're not relatively prime. If they were, we would get a primitive Pythagorean triple, which would be another type of triple here that we're not concerned about. But that's really it. We have m and n, so we can plug it into a, b, and c, and we get our values, and then all we have to do is double check that we have what we want. Does a squared plus b squared equal c squared? And does a plus b plus c equal 1000? And indeed they do. We have found the Pythagorean triple that we're looking for, and the product is listed below. Thanks for watching. I hope you've enjoyed. Make sure to like and subscribe, and I'll see you next time.